Hi guys, can y'all hear me? Okay, so we're back into our, can y'all hear me? We're back into the setup here. Alright guys, let's see how many people in the chat. We got how many people? 0 so far, let's go. I don't even know how, oh actually 0. Anyways, it's all good. I woke up late. I worked out yesterday, so I'm like sore because last week I didn't work out much in Willits in California. Alright. Anyways, we'll go over vacuum tubes and a whole bunch of other stuff and stuff like that. And also try to get back up to speed. 'Cause again, for those who don't know, last week I was all in the in Willits there. And someone see open up my Gmail because people want to message me. All right. They're getting a bunch of emails and messages. All right. Anyways, I'll move this over here. Okay, so I'll just check out how my audio is. Can you guys hear me? I'm gonna check right here. I'll play it. All right. Anyways, yeah, this is good stuff. And so on. And looks like 9/11 revision. I mean, Richard Gage is back on the architects engineers. Apparently there was like some sort of infighting going on even more or something. But it looks like he's using ChatGPT to make this up, to make this thingy here. So that's pretty wild. I'll do some screen grabs here maybe. I'll say Gage using ChatGPT. Is he using like ChatGPT? I think he is. Okay, because I can like really tell a million miles away. Richard Gage using ChatGPT. I'll copy it. Yeah, so I'm gonna do this. Yeah. So, anyways, there's the link in the Telegram. Everything that I cover in this will be there, and so on. And then also there's the threadcast here in Leo. Anyways, yes, Richard Gage is biggest clown in probably history. And so on, and also yeah. So this live stream I'll be doing. I mean, this Saturday's live stream I'll be going over with Alan Forrest, going over the JFK stuff. But he's got a lot of anti-Israel sentiment. So we'll see how that goes. It's pretty funny. Again, the whole anti-Israel. That's like just again, it's all just control opposition like narratives. So it's like people blame that as opposed to like every single country, every in other words, Freemasons. Anyways, let's keep going further. Okay, so I'm gonna just go through my thingy that I had saved over here. Vacuum tube. Okay, so someone messaged me on YouTube. Okay, this one here. I'm gonna go over the math stuff first, and then yeah. So vacuum tube is actually very interesting. It's actually John Hutchison says that's a key for noobs to get involved in the what's it called? Hutchison effect, how to replicate it, learn about vacuum tubes, and so on. And I'll be uploading a Hutchison video that I did. I did many hours of filming at his lab. It was pretty amazing. Yeah, anyways, let's go back here. Okay, so first of all, this guy asked me a question. If fx is a polynomial, can you explain how p double prime of x values of c minus and c plus are different? What in the world is this guy talking about? Okay, this is let's see, where's my Steam? I need to update these. Go to the Hive. Okay, so moved it over to Hive, and I don't like this Hive website. I like this Hive website. I gotta switch it over. Okay, this is reblogged something. Okay, yeah, so what was the polynomial? I think I made a giant, is this the giant video? No, this is, yeah, this might be. Yeah, this might be the giant video I did. This was, how many hours? 1.5, yeah, 1 hour 45 minutes of proving just one little thingy, proving this formula. So now almost 2 hours to prove this formula. Pretty wild. Prove this formula. Error bound for using Simpson's rule is so if you have the fourth derivative is less than k for all that, then the error is this. I think it's like if you're approximating. No, this, yeah, the error here is going to be less than this one. So basically, recall definition of Simpson's rule. Basically, you approximate a curve using parabolas. Interesting. So basically, it would be summation. And notice it's a summation. I think it's a summation. Suppose that this is less than k for all of that. Then this is the error when using Simpson's. Oh yeah. So suppose the fourth derivative is less than k for all x in between these two. Then the error is this thingy, this giant thingy. And again, simplest rule is basically the derivative. I mean, the integral is equal to basically you go delta x times yeah divided by 3 times fx blah 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 blah. This is all just using parabolas, and where I think yeah it's all parabolas. Interesting. Yeah, so it's like a curve from each little segment, and sum them all up, and then you're gonna get an error according to that. Okay. Yeah. So I go through this one here. And then the question is, what in the world is this guy talking about? Okay, if fx is a polynomial, can you explain how p, this is 1, 2, 3? Let's see how many does he have? How many does he have here? I'll just copy and paste here. 1, 1, 2, 3. Okay, so he has 3 derivatives. And where's the c? What is he talking about? C, right? Oh, this is left side of c and right side of c. And what is c from c to b? Integral. I'm trying to remember what in the world I did. Okay, so what are this guy's talking about? How this one values are different. What is this guy talking about? Where's that right side of C? Okay, oh, it's midpoint C. Okay, so midpoint is this one right here, left and right side of it. I'll say I'm not sure what you mean. Which timestamp are you referring to? Values of the derivative can change depending on the position on if x is on the positive or negative side. Something like that. I think that's what he meant. Plus C is on the right side because I just said yeah. C is 1 second. Yeah, so C, yeah, left side I put a negative, right side's that, yeah. So anyways, so I don't know what the in the world's got. Okay, anyway, so that's that part. And then see some other, I think someone on TikTok message. Anyways, we'll go over what else I want to go over. Yeah, so this before we go further, this is on the Hutchinson effect stuff. So I have on my dashboard, I have an unlisted draft video. I'm actually adding like a few more hours to this one. So it's John Lab, and we did some quite amazing stuff here. We went over. So this I'll be uploading this well once I edit it and make it nice. And there's John. I said to him this unlisted one. So we went over a bunch of experiments. We actually did RF heating as well, or radio frequency heating, and it was quite freaky. It's like you literally, it's like touching. It's cold, but my hands are getting hot. My arm is getting hot. I'm like, what planet am I on? All right. So we went over a whole bunch of stuff. We did testing of our radio frequencies and so on. So this is a vacuum tube, like radio receiver, I believe. And he'll go over the vacuum tubes in here. That's early 40s, okay. Yeah, okay, so it's gonna be pretty amazing. And then he also lifts it like 80 pounds, and he lifts it, and yeah, and also yeah, he had to go to emergency room the day after I left California, and then but he's back home now. I think it's something to do with his prostate probably, or something like that, because I think he had surgery to reduce that, but he should be better now. He's still going strong. But yeah, so there's John lifting a 80 pound like 19 pre 1940s a vacuum tube radio transmitters, but a bunch of vacuum tubes inside, and basically think of vacuum tubes as the transistors of modern day. Yeah, so he lifting it like it's nothing. That's pretty good. And there's the cannons there, and what's actually quite amazing is this cannon. Yin Gas, that's grandpa designed it, and I was told that I was told that he was actually like in World War II. They actually locked him up in a hotel to finish the designs of this. So it's pretty wild. All right, and then the whole bunch of gears in this setup here. Okay. Okay, so you can increase what kind of signals you get, and so I'm just using these all these analog mechanical gears and so on. Okay, so I'm gonna keep going. What he had in here, and then this is when we were listening to some radio transmissions. So here we're running these vacuum tube setup here. I think he said one of them was vacuum tube was faulty, but we're still able to get some signal. I think he was getting to the base signal for like ham radio guys use. Yeah, we go to the antenna, so we have it running now. So it's gonna be like one of the first. I think it's probably the only video ever made where I'm like in his lab doing random testing, where as opposed to just talking and so on. Let's go see some other stuff. Yeah, he's all using vacuum tubes and so on. What else we have in here? What I'll do is I'll just put a summary right here. Summarize it. No, actually, I can't summarize that. It's unlisted. You should be able to. See if I can summarize John Lab. But yeah, anyways, that's a draft video. I'll be uploading a better one. It's unlisted right now, and so on. All right, so that's John Lab. And then it shows the antenna. Let's keep going further into this. It's quite amazing. All right, let's see what else we had in here. Yeah, we go to the. I think we show the antenna here. Yeah. The antenna is basically a giant wire, like a giant. Well, this was like a high wavelength receiver there. So there's a giant, just a wire. Okay, yeah, so that's epic. Okay, so John is he's basically dropping knowledge on me nonstop. Okay. Oh, and this one here, we were trying to find out what this was. Okay, then I'm gonna screenshot and find out what this was. Okay. Okay. Yeah. And then let's go back here. I'm gonna go grok. What is this? What is this device? Okay, what is this device? Okay, what's this device here? So this one here, anybody know what this is? I think yeah, John didn't even know what it was. He said he looked pretty cool, so he wanted to get it. Let's see what it was. Okay, I was using expert. Let's do auto. Okay, it's auto now. Featuring base and arm of the stylus, cylindrical odometer style levers, jazz. Stamping or printing consecutive numbers. There's no stamping. No, that's not. That's in the background. No. I'll have to crop it all out. Okay, so what I'll do is I'm gonna do this GIMP right here. Okay, so I'm gonna say well before I ask that, and also notice a GIMP. Why does GIMP have an inverted pentagram? Then unbelievable. Like Freemasons run the world, yo. Anyways, keep going here. Okay, so what I'll do is I'm gonna stop this. Think incomplete. I don't want any thoughts. I just want to stop it, and then I'll go here. Okay, and yeah. Anyways, we'll go over the vacuum tube stuff, but it's all related. Like, what in the world is this device? I'm gonna go and do it like this, just so that Grok doesn't get confused at what this device is. Okay. Yes, it doesn't get confused with the stuff in the background. Yeah, yeah, that's pretty cool like that. I'm pretty sure this is part of it. Okay. Yeah, so there's no stamp thingy. I just want this thingy, nothing in the back. All right. Yeah, it's good enough. 1 second, peeps. We're gonna find out what this device is, and I'll tell John what this is once I find out. Because Grok's picking up stuff in the background. Yeah, so note to self, take a photo of it in like clear background. Okay. Okay, it's getting. Oh, whoops! Make it around this. Do like that and like that. All right. And then these giant balls. Like, what in the world are they for? Okay, one interesting topic. Crook's tube, earliest CRT, upon which Maltese cross was displayed. Interesting. All right, so you're on another level. Yeah, you're on another level there. So Toxicam at 777. Yeah, so we'll go back to tubes because again, John says for noobs that want to learn about Hutchinson effect, try to replicate it. The first thing to do, he says, learn about vacuum tubes, and so on. Eric Dollar would be a wonderful guest for results on this topic. Yeah, yeah, definitely. If you can reach out to him, let him know just to join the show. I think John watches his. Yeah, tell him John Hutchinson watches his stuff as well. Oops. I'm gonna remove this. Okay. But the thing is, I want to find out what this device is. Like, what in the world is this device? Okay, and what I'll do is I'll remove the background just so it's easier for Grok to figure out what in the world this is. And then I'll do a reverse image search after. I should have done that first, but whatever. I wanted to get this done as well. Whoops. This removed. Yeah, I think this is okay. This is also there. Aaron Murakami also, and of course, Hudson. Yeah, the thing is, people have to realize, like, I'm a very, very simple person. Like, John's got videos of things levitating, okay? So, in other words, all the world should be focused on getting things levitating. That includes Eric Dollard or Aaron Murakami. Like, we need to figure this out and then move on. Like if a person like here who does mostly math videos and 9/11 can uh, modify my schedule to learn up on this, y'all can do it as well. All right, so that's this one. I'm gonna save this. I'm gonna save this. And man, this is yeah, it's the only downside about like uh it was one of the downside. Like, how am I supposed to find stuff on a Mac? Like this, what is it? I can't just copy and paste stuff. Like, where am I? Documents, download. Just allow everything. My goodness, downloads. Allow. It's just so trash. Okay, pictures. Where do I find stuff? Other locations. Okay, volumes. Where am I? Okay, I'm gonna just go here, save it. Dollard and Bert have been running Esoteric Energy Conference for years. Some excellent team tech and info. Yeah, I know, but John has videos of things levitating. Okay, it's like that trumps any conference you'll ever go to ever. Right? People can talk and say things. Give me a device, I'll power my thingy and that. Or but this guy's got a video of things levitating. That's quite wild. So in other words, what I'm trying to say is, um, name of the game is anti-gravity. Okay, there's the untitled. Okay, so move it here. Oops. Now how do I move this now? Everything's gone. It's like this is just so annoying. I just want to save this in here. Can I move to that? Okay, I'll call this device. Okay, and now I'll do. Okay, now I'm gonna close this because this is just trash. Okay, now I know where this is. I'm gonna go and okay, we'll call this device JPEG. Oh, PNG. Yeah, JPEG is fine. Okay, let's see how it looks like now. Okay, there it is. Okay, so we're gonna ask Grok what in the world is this device. Um, yeah. So what is this device? Edit. Okay, I'll cancel. What is device? Okay, and then now there it is. Okay, so now we have that, and I'll do this right here. So there's the device. I'll post everything everywhere. I should post it here as well. What is this device? Okay. And identifying it. It's vintage mechanical tachometer, also known as a revolution counter or RPM gauge. It's an antique tool used to measure the rotational speed and revolution. To use it, you press the pointed end against a rotating shaft or disc, which advances the mechanical counter. There's no counter. Okay, I'm gonna have to do everything. Okay, I'm gonna how do I just trash this? Okay, I'm gonna start this again. There's no mechanical counter. Is this the rotating counter? Yeah, we're gonna go back again. I'm gonna go back here. Hello there. Okay, epic stuff there. Okay, Mystic Bazaar is in the show there, and yeah, great work on your stuff. Yeah, and I'll ask Judy Wood about interviewing you once I get a chance because you know, because once you talk to her, she can't stop talking. I'm like losing my mind. Anyways, what is this device? Okay, I'm gonna go expert thinking. Like unbelievable. Just think it. Okay, and now so we have that, and I'm gonna go right here, and then I'm gonna do reverse image search. But first, I'm gonna post this as well on here. Edit premium. Yeah. So all right, and so there's both photos. Okay, so now it's looking at there. I'm gonna go and Google images, reverse image. It's pretty powerful. Okay, and just expand. Like this is just so. I want to make it bigger. Now it does that. Like what is this happening? I just want to make it bigger. Google needs to like just trash. Just make it bigger. I can't even do anything. Okay, please. Okay, there it is. Visual matches. Oh, I think we got it. It is. It's a diamond cutting for hobbyists. It's a cutting tool? No. It might be something like this. It is a cutting thing. I think it is for cutting. It's a cutting machine. I knew it. There's that because there's a wheel there. Okay, the diamond cutting machine. Ah, that's pretty cool. So it's a diamond cutting machine. I think it's a diamond cutting machine. Yeah, yeah. So it's Dutch. Okay, it looks really, really similar to this one. So we found it. It's a diamond cutting machine. So the question is, how in the world does that work? It is a diamond cutting machine. Okay, I'm gonna go to message John. Okay, lone survivor with shipwreck. I figured out, yeah, PS John, I figured out what that mystery device is. The diamond cutting tool. Um, mystery device in your lab. Okay, so here's a link to another one. Okay, so there's an auction. Yeah, so it's a diamond cutting tool of aluminum, brass, and gunmetal construction on a cast. A Dutch diamond cutting machine. Okay, or machine. And okay, now this is yeah, machine. And I'll send this one here. Looks like a centrifugal governor. No, it's not. I think it's a diamond cutting tool, as in this website. Okay, and then I'm gonna go just auto picks whatever. Okay. Yeah, so it's and then how does it work? Okay, and then we'll go over here, diamond cutting machine. Okay, I'm gonna see if there's actually, and then we'll go over vacuum tube stuff when I get a chance. This will up everybody. Where's that tool? Okay, it doesn't have that. Yeah, this is a high resolution. Okay, yep, so right, bunkholes and cross between the auction listings. Antique Dutch, likely dated to 19th. Okay, made of brass. How does it cut? You just cut and polish diamonds by hand or semi-automatically. The operator would rotate the wheel via a pedal or belt not shown here, guiding the diamond along the precise angles to create facets. The counterweight system made it easier to maintain consistent pressure, reducing errors in the highly skilled craft. Okay, so that's what it is, and so on. And I'll send this photo to John. Okay, I'll just say this. It's a diamond cutting tool. It's a diamond cutting tool. And I'll post this on also Threadcast, so that's it's there on the blockchain forever. Okay, so that's what it is. And now we'll do this thingy. And back to this. This one. Oops. And send it to John. Okay, it's a diamond cutting tool. Yeah, yeah. Well, what mystery device in your lab is? It's a diamond cutting tool. There's a link to another. Yeah, so that's the mystery device. Okay, so we found it. We Okay, this is some money printing setup there. Okay, what else we got in the show? And also, yeah, so Mystic Bazaar's taking over the TikTok game. Accordingly, I think I'll post this right here. Yeah, so Mystic Bazaar is actually taking over the game. So guys, for those who don't know, Mystic Bazaar on TikTok, 11,000 followers, taking over the game, and it's got all 9/11 stuff there. It's absolutely epic stuff there, taking over the absolute game. I'll yeah put a link that I'll share that as well later. But anyways, or maybe, whoops, I'll just Mystic yeah, I'll just refresh this. I'm gonna forward this thingy, Demius links, and schedule it at, let's go 14:22. Okay, let's go at today's gonna be scheduled at 2 p.m. All right, so epic stuff. Keep up the great work, Mystic. Okay, that's what did I scheduled. Okay, so anyways, so that is, we found out that device. So anyways, so here's John's lab that I was in, and we did a bunch of experiments and so on. I want to go over some here. We were listening in on stuff here. And but I want to show you the RF frequency one. It's absolutely amazing. And then this is the one like he has a the only one in the world with this device, and it's like a it's like connects to a it connects to a anti-aircraft like cannon, and then this moves with it, and then you use a telescope or the binoculars, and then you fire it. You press a button and it automatically fires the cannon. Anyways, I think, oh, I had him on an operation here. Where's him operation? So anyways, so this is a draft video. I'll be uploading it later and so on. Yeah. Anyways, we'll play that later. Yeah. Thanks. Anything about the planes popping off at the moment? Yeah. Yeah. Definitely planes. Because it's like a personal thing. Everyone's been on a plane. You know, it feels like, and now it's like realize, hey, wait a second, holograms. I've never been on a hologram plane. Okay, there's Mr. EVO. There's a cannon he built. I'm gonna just keep going through. This is gonna be one of the most epic videos. Because it's probably the only one ever where John's actually in the lab testing things out, just running his operation as he is. We went over a lot of stuff. Oh, again, here's some static stuff we went over. And John is like literally like laser man. Okay, so here's the Van de Graaff generator, and what he also said was, if you want to create miniature ball lightning, put a Van de Graaff generator outside in the below freezing temperature, and then yeah, and then just run it, and then basically you'll have he saw like sparks, like a ball like half an inch maybe or something, and then floating around like a satellite around the ball, around the Van de Graaff generator there. It's pretty amazing. And this is like some has some like gas in there, some neutral gas. But anyways, he's gonna run it. Okay, there's John. Okay, now he's gonna spark it. Right, let's go back here. Wait, he's gonna do some sparks. He's like punching it. Yeah, there's a spark there. Oh, there. Hopefully, okay, John's taking with our team. Wait, John's gonna. The dog actually ran away once we got the tail running. He just runs away. He can like sense we're up to no good. Okay, he was punching it. What? I want to see the sparks though. I want to. I want to screenshot when he touches it. Okay. Oh, there's a punch. He's gonna. Oh, it doesn't show it. Why doesn't it show it? The camera doesn't pick it up. I saw it in real life. Oh, there's the spark. There's John. Oh, it connect. No, oh, there's a reflection there. Oh no, that's double one. Notice how fast the light is. It connects from here. Yes, because remember, this thingy is not the one that's charged. This is this Van de Graaff generator is on the back. The charge goes to this ball and then to his hand. Oh, look at that! That's amazing. Absolutely amazing photo. So somehow magical charge goes into there and there. Okay, so John Wilden. Okay, oh, Yin Gas is in the show. Okay, epic Yin. Did you hopefully you watched that video? It was pretty epic. Yeah, so Yin Gas is in the show, and hello from Austria, and yeah, and that cannon I showed earlier again. Yin Gas's grandpa designed it. Like that's quite fascinating. Okay, so this is John Wilden. Okay, there's John Wilden right here. So anyways, I'll put in a threadcast just because so everybody if you're posting a threadcast you get upvotes and you earn crypto. Anyways, so John's like punching these like a man, and I'm like you'll see me hit him too, but I'm not doing this thing. I'm not as powerful as this guy. Oh, okay. Oh, there's another spike in there. That's pretty cool. Whoops. Go back to the see what we get here. Oh, there it is. So John's just going straight on and punching this, and so John also told me that like he cut himself with like a machine before, and he would instead of like going to the doctor whatnot, he just puts it in the cold water and then he puts a crazy glue on it, and it just like heals up instead of doing surgery. I'm like, my goodness, and he showed me it. I'm like, this is quite amazing. So he's also a doctor. Okay, so here is the RF generator. Okay, so my hair's growing, I think, from this machine. Oops. Guess- Okay, so anyways, yeah, so here's the. Okay, so this is the RF thingy. This RF heater. Apparently, it's used in like medical mumbo jumbo before. It's pretty cool. So it's like a microwave, but it uses radio frequencies. A microwave is like shorter, more powerful. But what's cool is you can heat so the whole arm heated just touching this pad, and the pad is cold, or like the pad is just normal temperature. Yeah, yeah, the only thing bigger than anti-gravity and free energy is what's it called? Hair growth. All right, let's see this here. And also, yeah. Yeah, so my whole hand gets hot and my arm too. It's pretty amazing. Okay. And then you get an increase of power and so on, and it's quite ridiculous. Uh, and I put it on my head, and he's like, "Yeah, be careful." I'm gonna go faster. Okay, so I'm putting on my hair. Okay, so John says be careful. You better listen up. Okay, so I was out of there ASAP. Anyways, I'll fast forward here. Okay, and there's Mr. EVO. All right. Okay, who's in the? And what else did we ended up doing here? Then I filmed a bunch of stuff later as well. And here is a we turn off the there's a barium titanate for energy device so on or like, but anyways, and there's the teletype setup there that you can send transmit and so on. But this is like one of the most mechanically advanced engineering thing I've ever seen. It's so little. Okay, it's like a mechanical printer. It's like how to, so when you type and then this whole thing needs to rotate the paper, move the paper, and then type. But anyways, the paper he got loosed and not on. But anyways, then I was reading documents and so on, and interesting. Yeah, he used to live at 911 Dublin Street. Okay, in Vancouver, BC. Okay, you can't make stuff up. Anyways, so that's that part. Let's see what else we had in the setup here. I'm gonna go add some notes in here. It's messages, TikTok messages. What did I have open on TikTok? Okay, this guy here, I think. Okay, I want a miniature version of it. Yeah, definitely. I can ask the guy who made this to give you one, or just a full size. But again, it takes like 48 hours. I want to get a photo from Judy Wood. Because she actually has one. Okay, this person sent me some stuff. Here's a nice video on eddy currents and how induction vortex EM. This person, I have no idea who this user is. Oh, this nice video on eddy currents and how induction vortex current, electromagnetic induction, thermal effect, only materials with magnetic conductive properties can heat. Okay, let's play this video. Okay, this is like AI. I don't know. This is real. Oh, so that's why eddy currents are called that, because it's literally a vortex, literally ether. Yeah, interesting. Yeah, that's quite interesting stuff. This is private video. Okay, this is I'll put a fire. Okay, this guy's sent me a bunch of stuff here. So, anyways, um, yeah, okay. So now I'm gonna go over vacuum tube. So vacuum tube. And the reason is because John actually says it's the best thing ever. So this Rody Matrix actually tagged me in this. And he tagged me a bunch of stuff here. I gotta check a bunch of messages. Okay, this is a scam. Report post. Spam. Or actually, what was this guy here? Tom Pump Fun. Okay, so Pump Fun is it back? Airdrop. No, that's definitely a scam. Committees. So this guy is definitely a report post. Spam. Okay. Let's see right here. International fraud. Donald Trump, the star timestamp due. Okay, this guy's sending me a bunch of stuff here. What's it saying here? Okay, anyways, this is a bunch of paperwork. But this one is pretty okay. Anyways, I just want to go to where did it go? Oh, this is timestamp. Okay, timestamp wire. So this is the Hudson fact. The John Hudson interview. All proportion to Ventura. Yeah. So yeah, they all are related. But anyways, so John Hudson is named the game. So listen what he says. Listen what he says. He says, well, how should people? What's the first thing they should learn if they want to try to replicate the Hudson stuff? Yeah, so again, he's using T. Townsend Brown. This is 2012. He's right. It's all the same thing. He's doing Thomas Townsend Brown experiment when he had the wire there, high voltage, and sometimes he said he put a wire so it doesn't fly out super far away. No, and he said oh combinations. Okay, so he would have high voltage, and then he would also use the frequencies and so on. Oh, can't hear your video. Okay, someone says can't hear my video. Oh, I had it muted for some reason. Okay, okay, so I'm back on. Thanks, guys. I'll play this back on. Go back here.
Replication, and a lot of people didn't know.
Seems to interfere with the fields, and the fields seem to go are very transitory now to the point
Oh, it's still.
where the New Westminster came here and said, "Well, I'm getting complaints from."
Is it still not hearing it? Oh, it's on Teams. Okay, this is a. Why does it do that? Just. Okay, auxiliary. Teams mute. This. Okay, it is playing. Yeah, you should be able to play it now. This is working now. Let me know if it works. You guys should be able to play it. Let's play it.
Cracking and then citizens in distress, so I had to actually start downplaying. Oh, I don't even turn this stuff on. Is this for a show?
Well, there was a lot of confusion also because it was filmed. You did a lifter replication, and a lot of people didn't understand that because there was a wire suspending it. The point was you were using a single wire transmission system to make a really heavy object move. And I think people confused that for really the classic Hutchison effect. Do you think that's just something that over time people will kind of forget about, or?
I don't know. I seem to get an email once in a while, you know, screaming, yelling, you got wire attached to that thing, and I said, well.
And also, guys, yeah, I was playing the video of the Hudson effect the whole time, and nobody told me that the video was muted. Okay, so like, it's just this thingy when I have Teams. I needed to mute that and unmute this, so now I forgot to unmute that. So, anyways, everything should be playing.
All I was doing some also T. Townsend Brown's work and the Hutchison effect combinations.
Oh, sure.
I actually had high voltage on there, and also there's the Griffin film one, where I did literally have a string onto a toy UFO, because simply we want to film something. If it's going to fly off, we don't want to go spend time trying to find it over there or over there. So it was suspended right there, and you can see it where it starts to do its weird little movements. So if it was to actually go up in the air too, it would just come back down the string and captured by two cameras.
Oh, sure.
One right here and one over there, which Peter did do actually.
Now, in the case of like young people who might want to follow in your footsteps, what do you think the best thing for them to start out with would be?
I think actually for them to study vacuum tube technology and actually Tesla's work.
Oh, okay, so Tesla and tubes then.
Tesla and vacuum tubes.
I think that's also kind of related to the Moray tube in some ways, right?
The Moray tube is quite an interesting area to get into too, and that's a whole different area of alternative energy. Actually, it's kind of like the pre transistors.
Yeah.
That Shockley came across what this was.
Okay, and also interesting, he says a Moray tube. So the Moray tube or Moray device. So reading George Hathaway's mind-bending book, mind-bending George Hathaway PDF. So he actually the person like the Los Alamos the same guy at Los Alamos that went to quote debunk the Maury device was the same one that was sent to John Hutchison when they were doing the filming and the report, and then which they never showed the video and so on. Where's the mind bending PDF in here? Okay, we'll have to go like this. Okay, mind bending, this one right here. Okay, this is a good document. So if you go to Moray, John also said that he had parts, all the parts to make a Moray device, and would point out to us what Moray did to get his device working. Apparently, he was able to get free energy device there. Dollar speaks of Farnsworth, son of TV tube inventor, claims to have created something resembling a tiny universe inside the tube charged with AHP. Yeah, I actually saw something like a dollar had some sort of galaxy in a tube. That's pretty interesting. Some Moray device here. This was a famous case of Moray in Salt Lake City, perfected series of devices extracting considerable energy from a single wire antenna and good ground earth. So basically, wire and ground earth, and you get it. And then I think the exact same guy, yeah, Freeman. I think he was sent to do the debunking, but anyways, this guy here, Freeman, was the same guy at Los Alamos. So scientists from Bob Freeman. Science from Los Alamos, and Bob Freeman was the guy that sent to pretty much debunk that. Was clearly the most skeptical group. He was apparently the main man that Los Alamos would send to debunk claims of free energy. Was asked to pass judgment and so on. And yeah, he would say like, oh, John has some sort of secret device in some locked room, and then we unlock it. There's nothing there. Anyway, this is a good book. It is, but it's pretty interesting just to grasp some of the history from George Hathaway's side. And so on. I'm almost done reading that, or like halfway at least. So I'm gonna go and I'm gonna write this Hathaway book. But oh yeah, so anyways, Maury device. I'll probably do that later. George Hathaway book, mind bending. Okay, and I'll post this on here as well. And yeah, so make sure to download that and so on. And again, it has to spell, whoever uploaded this spelled Hutchinson wrong in the URL. Hutchin, they also put an N there. And it's quite interesting. I was going to go with some other stuff in here. But I forgot that. But anyways, so vacuum tubes is the name of the game. Vacuum tubes. So according to John, read up vacuum tubes. Okay. I'll send that there, and then I'll put this here as well. And again, guys, let me know whenever audio is not working, anything is not working, and so on. Son of yeah, actually, I think I've seen that part where Dollar's talking about that. Anyways, let's continue further. So vacuum tube. What in the world is a vacuum tube? So, so here's what vacuum tubes look like. Later thermionic. I'm gonna go make this 12, and then this is PM. Mostly miniature style, some with top cap connections for higher voltages. Yeah, so we got this stuff like this, and these can pick up or amplify yeah, voltage or even radio receivers and so on. Okay, so it's an audio power amplifier. The hot cathodes emitting their distinctive red-orange glow. So you can amplify, yeah, audio power. Okay, let's see what this says here. So a vacuum tube, electron tube, thermionic tube, British usage, or tube, North America, is a device that controls electric current flow in a high vacuum between electrodes to which an electric potential difference has been applied. So basically you have, yeah, basically a vacuum, and you have electric difference, potential difference, and then you heat a filament and electrons fly over. That's pretty much all it is. It takes the form of an evacuated tubular envelope of glass or sometimes metal containing electrodes connected to external connection pins. The type known as the thermionic tube or thermionic valve utilizes thermionic emission of electrons from a hot cathode for fundamental electron functions such as signal amplification and current rectification. So you can turn AC current into DC by pulsing, so you have it turned on only when it's positive. So you always have positive DC as opposed to the negative side. So so here is the thermionic emission is a liberation of charged particles from a hot electrode whose thermal energy gives some particles enough kinetic energy to escape the material surface. So basically, I think of it like the sun. Just heat it up. The particles, sometimes called thermions in early literature, are known to be ions or electrons. Thermal electron emissions specifically refers to emission of electrons. Yeah, thermion electron, yeah, and occurs when thermal energy overcomes material's work function. Okay, basically that's the ability to escape past the as minimum thermodynamic energy needed to move an electron from a solid to a point in vacuum immediately outside. Okay, so basically heat this up and then electrons fly out. So that's the filament. But now you're going to be in a vacuum, so there's no air, and it's going to move over to the potential difference. So if you have a positive, negative, then it will just fly over there. And the question is, what in the world is positive, negative? And that's probably some ether mumbo jumbo. Okay, so that's what this is. Yeah, so basically you have a part here, you heat this up, and then this flies over. Heat it up, fly over. But you can do a lot of stuff with that. You can do power amplification, and so on. See some more stuff right here. So tube terminals. So here's a plate. This is the grid right here. So this one, if you can amplify setup here. So here's a filament plate. And let's see what happens here. Representing a primitive. This is a triode. This is a grid here, so you can actually amplify it by flying over it. We'll watch one of those old school videos. And this is similar to what John had. These little grid setup, and there's the vacuum tubes, and you rotate these and adjust the setup there. Cutaway drawing showing construction of low power diode vacuum tube. So there's a heater, anode, cathode. Oh, also another thing I wanted to show was. So John actually, when I was reviewing his papers. When I was reviewing John's papers, I actually found a bank statement, the only bank statement in his papers. This is from what's it called? From January 2024. And then I see it, I'm like, okay, and there's a John Hudson PayPal. He received 350 USD, and then I looked at my thing and I'm like, oh, that's me. So if you 350 USD. Yeah, so or let's go to samples. I think samples John. I think this one. Oh, yeah, just paid 500 CAD. Yeah, so I paid 500 CAD or 350 USD. So said John Hudson, and the fee was $10. Yeah, so this is literally mine, and this was the samples I got. These amazing stuff here, and he didn't even. Then he didn't even remember it was me. And this is from January 23rd, and the money comes into his bank on the 24th. You can't make this stuff up. And I have his bank statement of him receiving this, so that's absolutely ridiculous. Like, it's bananas, guys. It's actually bananas. Let me paste this right here. Okay. Yeah. Yeah. Anyways. So that's the vacuum tube. I'm gonna go watch the video on how it works exactly. How a vacuum tube works. I want to see the old school ones. Yeah, this is the one that John sent me. Let's play this. Original film electronics work have been edited and annotated by Rob Robinette. Okay, he's got two Robs in his name. Let's play this.
This is a diode, a typical two-element electronic tube. Let's get inside it.
Okay, diode. I'm gonna, if I can increase the volume here. That should be fine. Okay.
In fundamental.
So diode, two electrodes, plate, anode. So the plate is the anode. Let's go back here. So plate is the anode. Anode is like a plate, and then the cathode is the one that's heating it up, and then it's sending electrons. So that's the plus because the electrons are moving over to the no, yeah, that'll be the negative actually. But then it's becoming. Oh no, the cathode would be that should be the plus because it's removing electrons. So it's becoming more positive. Other one's becoming more negative. Something like that. Let's play this. Okay, so this is the anode, the plate, and the cathode is the one that heated up.
In fundamental operation, it resembles an ordinary single-pole switch. A switch that can connect, for instance, this battery and its motor load.
Oh yeah, so now it also acts as a switch. Again, it's part of the modern transistors. Now it's modern, and they don't need to do this. And it's also solid state, so you don't actually have a giant tube, a vacuum, and empty space in between.
One power lead comes to the anode, the other lead goes to the cathode. When this switch is open, the contacts are insulated from each other by a vacuum. or by some inert gas inserted into an evacuated tube under low pressure.
Okay, so or low pressure inert gas like argon or something. And yeah, so anyway, so when this is there, it doesn't go here. Cathode is kept negative compared to plate. I know, but the electrons are flying over it. Would this be called a plus or minus? Because this is a minus there. Okay, let's just see what they. I just want to see what convention they use for whatever purpose.
To close this switch electronically, all we need do is heat the cathode.
Okay, so you add a second battery. Okay, so see, this is a circuit right here. And now you have a switch that's the battery to heat it up. So all you do heat it up, or yeah, once it's heated up, you get a connection.
And give the anode a positive potential.
Oh, okay, yeah. So you are right. Yeah, so cathode is kept negative. So they call it negative. That's where the electrons are. I was thinking because if it's losing electrons, it becomes positive. Anyways, so it's a negative one. The anode is a positive. Cathode is a negative. So it heats it up, and there's a negative here connected over to this negative side. And then once it heats it up.
Then here's what happens. As electrons are emitted from the surface of the heated cathode, being negatively charged, they fly at tremendous speed to the anode.
Okay, so plate flowing electrons, flowing negative electrons. Hot is negative. So positive plate, and it's cold. Some cathodes directly heated with lower voltage. Modern tubes have separate heater circuits. Interesting. Yeah, so you have a heater circuit, and then there's the connection. So now you have a hot, and then it flows there. Okay, it's turning on.
In this way, a current-carrying path is formed, which closes our electronic switch and permits our motor to operate.
Okay, and before I go further, I'm gonna go drink some water and coffee, and because the other video wasn't working, I'll go back here to play. I mean, the sound wasn't working. Now you guys can hear the sound. I'm gonna go back to this part here, the voltage, the one where I'm testing out stuff, and then you guys can do whatever. And I'll just go drink some water. I'll be back. I'll get some coffee. Okay, so this is the one where John is wild in. Yeah, I'll go to the lighting one here.
Alright, guys.
We're gonna now we'll turn this
Okay,
guy off.
so now you can hear the audio now, and you can hear the sparks and John punching this. This is like this is a vacuum in here, and it's got some sort of gas, or I think it's vacuum or has some gas, and this reacts to static forces. But this is the and this Van de Graaff is literally just a high friction belt just going up, just going in a circle, like causing giant static friction, and then there's this basically it has charges flying off.
Okay.
Time limit.
Yeah, no, there's no time limit. You can do whatever you want. You're the time limit. Whatever you want. I'm gonna, so let me know when to, if you want. Oh my goodness, John. John is just careful.
That's electrostatic.
Yeah,
That's not with dynamic electricity. I'd be flying
Oh.
around.
Oh, if it's dynamic electricity,
No, it's just static.
oh, it's just statics, okay. And dynamic, can you explain dynamic again? Oh, and then,
Dynamic is like direct current.
okay, okay.
DC or high voltage AC.
Yeah, John's just punching this. Alright. Alright, guys. Oh, it's literally, John's powering it from free energy. Does that hurt or no, John?
No.
So, like, only the spark does it. Once you, so basically you're using yourself as like a current path, or how are you?
I'm on extra mass for him to have fun with.
Okay, yeah, so basically it's grabbing ions from you
Yeah.
and throwing it in there.
Negative and positive.
Yeah, but so only the spark hurts. Okay, so we have
I
some.
love the smell of ozone, by the way.
Oh, ozone. Okay.
Oh, my hair.
Yeah, interesting. Okay, so apparently ozone is a bit, can be dangerous. Oh, okay, so your hair's in there. Yeah, your hair's floating, and I think my hair's growing.
Well, good.
Yeah, I think my hair's growing. I'm gonna have a quick check. Oh, no, never mind. Actually, maybe. All right, guys. I think I got some hair growth. Okay, guys, we've.
National TV and
Yeah.
oh, we'll go to this guy.
Okay, what's this one here? So John is on.
RF.
Alright, guys. So John is entertaining us and enlightening us and scaring us.
We're gonna get Matthew's hair up here, so you can hang on to this and tell me what you feel.
Oh, I'm gonna grab this. Okay. So I'm grabbing this. One second. I'm gonna zoom out a bit. Okay. So I'm gonna zoom out. Okay. So I'm grabbing this. So we're gonna increase my hair growth.
Yeah, let me just try and find it.
So if there's one thing more world changing than anti-gravity and free energy, it has to be male hair growth.
Yeah.
A cure for male baldness. I think it's probably the only thing bigger than anti-gravity and free energy.
Okay. Oh, what is this supposed to do? Am I supposed to? Oh, it is. I'm feeling some heat-ish.
Yeah,
thing.
that's right. That's RF.
So I'm feeling heat, but this is not hot. I'm feeling it from my hands.
Yep, I know.
So I'm feeling. My hands are getting hot.
Yep.
This is not hot. I'm feeling like heat coming literally out of my arm. Okay, it's John's
Yeah.
and that's so that's radio frequency.
Yeah.
So he's literally so he's gonna melt me soon.
Yeah, well,
Oh, you want to put it flat like that? Okay.
oh yeah, it's more in my hand too. So this is RF at
Dosage in minutes. What? What? Go on.
500 watts, 27 megacycles, used in medical research for like diastolic.
Okay.
But it's a nice, powerful transmitter.
I'm gonna
It's
zoom
got
in.
history because Governor Jesse Ventura put a light bulb down and it lit up on its own.
Oh, Jesse Ventura lit up. It lit up on its own. Is that supposed to happen, or just you found out?
Oh yeah.
Okay, so Jesse Ventura, the governor.
The governor, yeah.
Yeah, the governor and the wrestler,
Yeah.
and the conspiracy theory documentary guy.
Yeah, definitely.
The death ray guy.
Yeah.
Yeah, that's literally doing. He put a light bulb with this and it started lighting up. But yeah, I can literally feel it.
In this way,
Muted. Okay, so I had to press it like hard. Okay, I'm back on, and now I'm muted. Yeah. So, anyways, yeah. So I was saying is, yeah. So basically, yeah. So Jesse Ventura, the Jesse Ventura, had to put a light bulb under this and started lighting up. So that's quite ridiculous. All right. Anyways, okay. I'm on. Okay. Night of the Originals in the show, guys. Okay, Epic's up there, and yeah. So also, yeah, Night of the Originals was interesting as yeah. So Keith sent us this thing here. So Architects and Engineers from Island True by Richard Gage. It literally looks like he asked ChatGPT to make him make him a setup here. This is all ChatGPT. I'm gonna go quickly check this. Audio okay now. Oh yeah, just because on 9/11 Originals here, we'll test this out. I'm gonna ask ChatGPT. Yes, I'm gonna ask let's go. I'll go Grok. Well, actually, we'll tag AI text detector. Okay, so we're gonna check if it's AI because I think he made AI. I'm pretty sure. AI text detector or paste text. Okay. Let's see this. Scan. Let's see if it goes. Oh, it's a human. We're highly confident this text is human. No way. I thought it was. Oh man. No way. Okay, so he's actually he's using human AI. How's he do that? 1% mix, 99% human. Interesting. Okay, anyways, so it looks like he probably just asked ChatGPT to make a setup there, and then he just modified it because this looks like this literally looks like ChatGPT. Anyways, it lately began refusing to write certain articles that it randomly wrote only a few weeks ago. Yeah, again, don't use ChatGPT. Just use Grok. I don't. Grok is and you can do the project setup too if you're on a desktop. So you can make projects, and it's much better. Oh, actually, I should have put this device here. Oh yeah. So I have a MES Hutchinson effect set up here. So make the project, and then basically you can add the sources whatever it needs here. Where's the mind bending one? God, oh, I need to get the mind bending one. Okay, so I'm gonna download this right here. I think I have this downloaded, but I want to just download it. Anyways, so I have Hutchinson effect here. Current research Hutchinson effect. I'll go to I'm just gonna put everything in here. Oh no, actually it was I think it was other files, but anyways, or Hathaway back to Hutchinson effect. I think I have a George Hathaway books random Hutchinson a 991. Where did I do stuff? Okay. Well, anyways, I'm just gonna put this right here. Books. Okay, that's in the book setup. I'm gonna go MES replication. I'm just gonna put everything that I put in here. Okay, I'm screwed. Where should I put this books? Okay, I'm gonna go back here. I'm gonna put the books in books here. Okay, I'll put this book in here, And the reason I do that is now because you could do the project and you can tell it what to do. So like it doesn't matter what the default it's set up here. I'm gonna throw this in here. Plus upload a file in Washington D.C. area, particularly north. To push the message, not truth. Okay. The data center frenzy is out of control, being built left, right. Yeah, but anyways, you can use projects, and then also another cool thing is if you're on Hive, you can actually train it, like train the public Leo AI. I'm gonna go right here, research Hudson. I think well, no, books in here. Hudson effect. I think it's in the books setup. Okay, books here. Okay, this needs to be rewritten. I hate how they wrote Hutchison. Hutchison. Okay, so there it is. Okay, so I'm gonna add this book here, and then I had instructions. Review the sources always. For every prompt, just in case there is info in them related to the prompt. Okay, so basically, whenever you ask it in this project, it will always review all these stuff. And we could we could do some stuff setup here. So we'll do some testing. And I'm gonna move this books here. Whoops, no, I can't do that. So there's two books. Yeah, I'm gonna do right here. I'm gonna ask Grok. Okay, we're gonna ask right here. Conversations or oh yeah. So summarize in a table John Hutchison's use of vacuum tubes in the Hutchison effect. Okay, so basically it will review these. So it provided this mind-bending Hutchison file, so it's gonna review every single one, and then I'm in the middle. Anyways, algorithms being updated to push the quote message and not truth. Well, that's just the way it works. But like it's like you go Google and so on. I go to YouTube. YouTube when they periodically they would go through a huge period of censorship. Like in COVID, they'll remove every single thing. So you need to always be like ahead of the game. Like understand that anything you type will be eventually removed if you're not or at least censored. Even because right now, the big one that I'm seeing is Substack is growing so rapidly that I think just heads up. Don't be surprised if all your stuff gets taken out in the future because it's getting pretty fast, rapidly up there. I'm gonna start setting. Okay. UFO detector. So you use a UFO detector based on vacuum tubes. And we'll go over to the other part. So Mystics Bizarre. I'm in the middle of a United 93 deep dive, and my ChatGPT is telling me that no plane crashed in Shankville, and also gave me 4 most likely scenarios. The episode. Yeah, Substack expected another trick, another black hole. And again, that's why make sure all your stuff is being posted on the Hive blockchain. And that's what I'm also doing here. I'll do this work one. So, do you remember I went over the Einol Dino's fundamental theories of an ether? So he actually gave me permission that I could upload this. The original paper can be found here, and I'll be gradually posting all of his stuff in here because again, ResearchGate is similar. It's like you have to graph centralized things will do centralized things. Literally an online Burning Man. Yeah, that's the name of the game. And like I think the first time that I started like thinking, okay, I gotta always make sure my stuff is backed up forever, is when I was working out at the gym and when I was in University of British Columbia, UBC, for when I think I was doing my master's or not master's, when I was doing my civil engineering bachelor's, and then one time I went to the gym and then my backpack got stolen, and which had my laptop, and then all my files are gone. So I'm like, all right. So that's when I started getting cloud storage like Dropbox and OneDrive. So anything I upload, any photo I take, gets thrown to the cloud. So it's like now, and then once I learned about Hive blockchain, and I'm like, all right, this thing is like magical. Now every single thing that's important, I make sure it's on there. So think about it like people are incentivized. They get paid in Hive tokens to store your thingy forever. And they don't want to ruin their cash cow, and it's like all over the world. So, and it's not in one person's hand. So, the articles are there forever, in my estimation. Even if I have to run my own Hive node, and I need to come up with a better system for posting on Hive. Yeah. Like what I mean is like post the actual article, like your Substack article should be on Hive. uh, either duplicate or main. Like think of your Mystic Bazaar here. So here's your Substack is big as it's again a lot of people are on it and so on, but things you don't earn from the post. So like this post should be on Hive, Mystic, right here, like because right now I think you're posting this and you're saying follow me on Substack, but like what I meant is, so this video like. What I was trying to say is you post your actual articles on Hive. Like not the actual, like I'm saying the actual article. We need a Hive codex. I was actually gonna do a Hive community for like a breakaway community website for 9/11 Truth, but I pretty much have the MES community one. It's just, but make it as a website. But anyway, so what I'm trying to say is post your article. No, Mystic, yeah, also is Mystic. Post your article, not link. Embed 3Speak videos as an article. I don't know. So like you post on 3Speak, so you had the videos. So I was wondering what I think you misread what I meant. So this article, this entire article right here. You post the entire thing on 3Speak. I mean on YouTube, and not YouTube on Hive. So this entire thing, and then if you need a video, if you want to embed a video, you can embed YouTube videos or 3Speak videos. I think that's I'm not sure if there's any other ones you can embed. So you could upload the video on 3Speak, not the Substack video, like not the actual video. I was copying my Substack over, but I can't upload videos that I've got saved. No, I know you upload the video to 3Speak. And then you embed the 3Speak video into your article on Hive. Okay, like I have to like. Anyways, so what I'm trying to say is here's a video. This is a Substack video. I saw that one. Where's the video that you posted? Where's a recent video that you've posted? Like, where's the video? Okay, plain or no plain? Is this a? Yeah. Okay, so this is a video that you posted on 3Speak. Why is it like cropped out? Yeah, so anyways. So yeah, so you can embed this as an article. So you go to Peaked again. Create post. And now you have the video, and now you go article, blah blah blah, article, blah blah blah. So you can just paste the thing and now it becomes an embedded video. So what I'm trying to say is you upload on 3Speak and then you embed it in there. So you could have two revenue streams there. But anyways, it'll be pretty cool there. Or you could do it on YouTube unlisted. So it doesn't have a Substack like Peak doesn't have a Substack like version. But eventually they'll probably have the same thing. Well, they'll host their own videos or use 3Speak in the backend. So because they don't do that, so anyway, so and now going back to the thing I was working on. So this one here. So I know Dinu. I'll show you the email. Dinu. Okay, so yeah, it's the fundamentals of an ether. He says, yeah, I asked him, hey, can I upload this on a Hive blockchain? He says, yes, you may publish my articles on the Hive blockchain. Just make sure you add a link to the original, and I may ask to remove it in the future for unforeseen. Okay, Mr. Bizarre says, oh, I get it now. Yeah, definitely. Like, I'm trying to, like, you have to realize, yeah, Hive isn't as big, but you've already earned a lot of cash on that. So your Hive accounts were $7 USD, and it's like, and stake type. No, this is taking over the game. And the other pro tip is post the article on Inleo instead. Like the thing is, Inleo you also if you post on Inleo, like here threads you earn not, but if you go publish, create post, you actually earn like testing blah blah blah. So the thing it's not as user friendly in my opinion as the Peaked, but you earn Leo as well. So like what I do is I usually I post on there, but for short threads for show I just use in Leo, and just because you earn Leo, which is layer 2 on Hive, and the Hive one. So if you go to blog, so where's the one that I posted? Okay, but 3 speaks are there, but where's the in Leo one that I posted? Yeah, so here is benefactor. Where's the benefactor notes? I think it's the notes. Yeah, so there's the notes right here, but yeah, it doesn't look as nice. Where's the notes? Okay, there's the notes. Okay, I'm gonna go to in Leo. InLeo.io. Yeah. So anyway, so I put in Leo. It just the formatting. It's not what I like, but I post it using in Leo. It's posted in Leo, so that I earn Leo, so 0.65 Leo and Hive. So this is I earn Hive and Leo, as opposed to just Hive. But then I would usually edit on this one because it just looks better on this on Peak. But anyways, so Hive is the next level. You can like literally use any website you want forever. Oh, I'm starting to publish on InLeo. It kept saying error, but I will go. But what was screenshot? Yes, screenshot errors and send me. Yeah, so you can screenshot errors and send me. But also what you can also do is on InLeo, because the founder, like the guys who run InLeo, they're very responsive. So if you just type feedback and then paste a screenshot and then be like be like yo error doing stuff or whatever, and then just do hashtag feedback, and then they'll review it, and then they'll tell you stuff. But also you can do also ask Leo, which is pretty cool. And they also have a built-in bot that everything is posted on the Hive blockchain, and keep that in mind. Like it's not like ChatGPT or X, which keeps all your data. Like they basically store the data and they do whatever they want with it. You can't access it like using like APIs or whatever. So this one you can go ask Leo and be like, what is a vacuum tube? Okay, and then and so on. Now we'll have the AI bot in there, and again, this is like decentralized stuff. It's like it's not a you don't need any permission. You don't need to yeah, you don't need to pay anything and so on. You don't need to give them your ID or anything. It's just we'll do it eventually. See if it loads up. Okay, a vacuum tube, also called an electron tube, is an electron device that controls electric current flow in a high vacuum between electrodes using thermionic emission or other effects. And this is the Ask Graphic guy. You can also tag him, you can also reply, and so on. Using thermionic emission or other effects invented in the early 1990s, they're glass closed. And you can also put a link and so on, and summarize it and so on. They powered early tubes, vacuums, amplifiers until transistors replaced them for being smaller, cheaper, and more reliable. Today they're using high-end audio gear, guitar amps, and some scientific instruments. Okay, so this is quite a while. It's 1904. That's when they're typed back to. Okay, so we got some early stuff. Anyways, so you can do a lot of stuff on Hive that mainstream, the mainstream sites can do. But this is again decentralized. It's like, and here I made a sent. I picked stuff here, so I made a sent. Somebody uploaded. Taskmaster uploaded myself. Okay, this guy's really big on Hive. So I got it 0.063 Leo, and Leo is it's like the best layer 2 on Hive token, and so on. And I have a whole bunch of that somehow. Anyways, so now you understand how it is. So what I'm trying to say is post your articles on Hive first, and then copy those onto Substack second. High power transmitting tube semiconductors would melt. Interesting. Okay. Oh, yes, semiconductors would melt, also predominant high power transmission tubes. Okay, anyways, so post these on your setup there, and what you'll see from me is like when I post on Substack, I like the email setup there, but again, I don't want this is a good article. You don't want this to be completely dependent on Substack. Because think about like in 10 years, 5 years, 100 years, 1,000 years, it's like you want your presence on this reality to be as you intend it to be forever. You don't want modified and whatnot. But also just for and the other one pays you as well. So but the cool thing is this one is email one. But this what I'm trying to say is Substack can be built on top of Hive. Hive can't be built on top of Substack. So it's like Substack, they can't, like you can have a Substack competitor on Hive, but you can't have a Hive competitor on Substack. So anyways, and that's what you'll see. All my notes are put on Hive, and then everything else is secondary afterwards. So if I go to this one, I didn't have notes, but I had it here. Like here, and again to illustrate, go to the notes right here. And the thing is, you could also do ridiculous things on Hive that you can't do anywhere else. Like this is a giant notes thingy. I'm not even sure how much I'm not sure you put all this notes in one Hive. Yeah, was a 10-hour video, and this is like literally like 200 pages or something. And now and if I go to the 499, I'll be starting to update this as well. This is the 499 first responders testimonies. I have a 300,000 page article. I mean, 300,000 word article. You can't put this on Substack. You can't put this on anywhere as an article. And this is all the 499 first responders testimonies. I've only gotten up to 116, so I need like 400 more, almost 400 more. Okay, microwave tubes, magnetron, klystron, also vacuum tubes. Yeah, okay, epic stuff. So I'm gonna go back into our nitty gritty. Okay, so anyways, go back here. So once it's yeah, so you have the electrons go here, but I want to illustrate the grid pattern because you can actually use as a radio receiver. So we'll go back here. So once electrons flow, you have the current. Now you can start our motor.
A current carrying path is formed, which closes our electronic switch and permits our motor to operate. You'll notice, by the way, that the direction of electron flow is contrary to the orthodox concept of current flow from plus to minus.
Okay, yeah, so this is interesting. So the flow goes from minus to plus. But why is it saying, oh yeah, but the current would be plus to minus. Yeah, so that's another thing in mainstream I never understood why in the world they do it. They have current going opposite direction. So it'd be like, yeah, so why is current in the opposite direction? And we'll ask, yeah, the thing is, yeah, so, okay, I'll go back to ask Leo, and I'll say, why is, actually, I'll go back here. I'll go back here. Why, ask Leo, why is current in the opposite direction of electron flow? So, yeah, current, you know, when someone says the current is going from positive to negative, it's like the actual, like, it's just opposite. I don't understand. So current vs electron flow. So current is just like a, they should have made it the same. I don't know, why are they making it different? Like, what's the point of making it different? So electron flow, conventional current flow goes from opposite. Like, what planet are we on? Electrons are going this way, but the convention is to make current going opposite way. Like these people should be arrested. So if you have a wire, electrons going this way, current's going this way. What in the world are we doing with ourselves? Like, what are we doing? Well, like, well, what planet are we on? The current flow through tube is rather small, not able to drive motor of any size. I think current flow is shown opposite due to showing whole flow could also carry over from chemistry. Yeah, but I just don't care. Like every single example of people say, yeah, like it's like they say the circuit is because electrons are moving, and then it's all of a sudden, yeah, but the current's opposite. Like, what are you guys doing to yourself? Anyways, what I'm trying to say is, mainstream's wrong. Yeah. So let's see what this is. Let's go back here. So tube with a higher power relay trigger with electron higher current. Yeah, I'm getting a call right here. Hello? Holly, what video, man? Kan we het zouden... Oké, Ibi batten... Ja, bat... Tam. Ja, wat zit op hals? Ja, oké, batten. Alright, anyways, yeah, so I might have to end the stream a bit early. I actually need to go and pick up my mom. She's like at a bus stop that needs, with a bunch of groceries. I need to pick her up. Alright, so anyways, so this is this thing right here. Yeah, so current flow is that Did not cars originally have positive grounds? Anyways, guys, we'll go back to the setup here. I want to finish this video, and then I'm gonna have to go run to the thingy, and I might come back depending on how long it takes. Yeah, so I might play a video for you guys, and I'll be back then. Anyways, I'll play this right here quickly.
Current flow from plus to minus. In the first place, we can rectify current with it, converting AC to DC.
Yeah, so alternating current to DC. So instead of fluctuating direction of the electron flow / current flow. Did not cars originally have positive grounds? Interesting.
We can do this merely by connecting an electronic tube in series with an AC circuit. As you study this circuit diagram, note that only each positive half wave.
Anyways, I'll be back. No, yeah, she's almost at the bus stop. I need to go. I have like a minute before I run. Okay, I'm gonna go run there. I'm gonna play. Well, I'm gonna go. I'll be back in like 5 minutes. Hudson Effect. I'll play this one here. What should I play that you guys will like? I'll play this one here. Hudson Effect compilation. Okay, guys, you guys are on your own for a few minutes. Yeah, I'm gonna play this right here. And I will mute my thingy, and I'll be back. Alright, I'm back. Put this away. Alright, I'm back. Yeah, so this cannonball, or actually a mill ball, absolutely amazing. It's like, okay, Tammy. Okay, you're like, yeah, I just got back from helping my mom out. All right. All right. Anyways, yeah. So again, when people talk about for energy, information, blah blah, ether, stuff like that. This guy's got a bowling ball already. I mean, this guy's got a mill ball levitating. Okay, this guy's got a giant thing levitating for like 5 minutes. Like water levitating. Okay, and I'm pretty sure I actually think I know what's going on. It's just I think radio waves are just electrogravitic, not electromagnetic. So that's a key point. And eddy currents. That's why it's called that. Okay, that's an interesting one. So eddy currents. I'll say, why is eddy currents called that? Okay, so we have, what is vacuum tube? What else do we have in this replica? Conventional current, the direction, was defined historically by Benjamin Franklin before we understood electrons, so that's why. So apparently it was before he assumed electricity flowed from positive to negative terminals. In reality, electrons' negative charge carriers move from negative to positive, opposite conventional. And this guy, Benjamin Franklin, was the cold fusion guy, who literally wrote about cold fusion, lightning strikes causing like metal to melt in his pocket. The conventional stock in engineering textbook consistency, even though actual electrons flow was reversed. For more, yeah. So basically, it was because of a mistake. Can't make this stuff up. Okay, so I'll just be using this stuff instead of Grok. I'm just using Leo because again, the cool thing about this is you don't need to sign in or anything, and it's like you never need to sign in or anything because it's all public on the blockchain forever. And so that's pretty cool. So anyway, so it was all done by mistake. All right, so we got it done by mistake. And now the other thing I was gonna ask is I was gonna ask something else, but I forgot. But anyways, let's go back into the thingy. Yeah. So anyways, so Tammy's late, no worries. And also, yeah, Mystic Bazaar. Hopefully, you learned how to post on Hive now. So this is epic stuff here. Now I'm just gonna start using that more often. And also, has a UFO detector. Mention of a UFO detector using vacuum tubes. He was determined to try one vacuum tube Tesla coil. Okay, there's vacuum tube Tesla coil and so on. And again, that's John using that. So go back to the video. This video is pretty cool. Actually, before we even get to that, John actually replied. Substack was discussing, and I don't know why he has to forward. Why does what email is he using? Brilliant, thanks, Matthew. Great fun. Now we know. Wow. So it was a diamond cutting tool. This device. And okay, well, once I'm done this this video, I'll play the other one. I'm gonna close this. Okay, so we got this stuff. Okay, this is a setup here. Rectifier. This is the thermionic emission. I'll keep this opened. Where's that video? The video just disappeared? Where's that video? What did it just happen to it? Let's go to history. Where do I go? How do I check history? History. All right. This one, vacuum tubes work.
Half wave of AC voltage will now.
Okay, so anyways, there's the amplifier, and or I mean, now we're talking about is it the amplifier or something else? Okay, no, now he's the rectifier. So now he's gonna rectify, which is basically turn alternating and to a direct pulse DC using a vacuum tube.
With it.
And also amplifier as well.
AC to DC.
Also amplifier too. Let's go back.
Direct path is formed, which closes our electronic switch and permits our motor to operate.
So amplifier, I think this is because it could just be turning on. It doesn't need to be an amplifier or a load or whatnot. Anyways.
You'll notice, by the way, that the direction of electron flow is contrary to the orthodox concept of current flow from plus to minus. In the first place, we can rectify current with it, converting AC to DC. We can do this merely by connecting an electronic tube in series with an AC circuit.
One second, my desk. So now it's rectifier tube.
As you study this circuit diagram, note that only each positive half wave of AC voltage will now produce a current.
Because this generator, this is a power transformer. So I need to understand what in the world's going on here. So this is plus minus. Okay.
current.
So single plate half wave rectifier equals 60 hertz pulse DC. Let's see how this works. This one is an interesting setup here.
When the anode is negative, the electrons are repelled and no
Okay, yeah, basically this is saying if you have an AC generator coming from AC alternating negative positive. So when it's negative, this becomes negative. This is also negative. So it's not going to be sending any electrons to it. And this one's always heating this up. So this is going to be a bunch of negative here. But that's negative because this thing's connected to is negative. This one's positive. Nothing's going to happen.
current flow.
There's no current flow.
In other words, because only the cathode
Only when this reverses, when this is positive. So only time that this can cause electrons to flow here is when this is positive.
can emit electrons, we have here what amounts to a one-way street. We can visualize the result of the tube's rectifying action with the aid of these two oscilloscopes. The one on the left shows alternating current coming in. The one on the right shows pulsating direct current going out. The applications of this basic rectifying principle are many and important. The second basic thing we can do with it is amplify. Here's how. Between the cathode and the anode of the two-element tube, which we diagrammed a while ago, we now place a grid. To this grid, we connect an input of some weak voltage, which
Yeah. So I just want to show the image again. This one's pretty cool. So you have pulse DC, direct current. It's just basically one-way charge. One-way current charge. And notice this one's negative. This goes negative and positive, and then why does it show both? I thought I had it both. Okay. Anyways, yeah. So anyways, you get the idea. Basically, it cuts off all the flip side currents, and now you only have the top part, and then you have that part there. It's pretty amazing. Anyways, go back to the amplifying.
between the cathode and the anode of the two-element tube, which we diagrammed a while ago, we now place a grid. To this grid, we connect an input of some weak voltage, which we wish to amplify.
There's guitar signal. So there's an antenna, guitar signal, or it could also be. And again, this is the thing where I always think electromagnetism is just either everything because it's so simple. So antenna. Notice how a guitar is literally a string, and you vibrate and you get sound. Okay, and the antenna in real life is just a string. Well, you can literally have a wire that gets vibrating from incoming waves, and then that's your receiving. So anyways, now you have a weak input. Watch what happens here. And then you put it in here in a grid, and now you have a high voltage hitting straight or a high current flow hitting this, and that somehow amplifies that reading. Let's play this again.
Perhaps that of a faint radio signal from halfway around the world.
Yeah, so you can also do a faint radio signal. Because plate not hot enough to emit electrons, only flow from K when... Yeah, so and also you're writing positive, you want P sufficiently more positive than K. What's P? Oh no, plate. So, and what's K? Cathode, you mean? And cathode's a C. I don't know. K, anyways.
Now let's see what happens.
Okay, plate, cathode, grid. Grid is much closer to cathode, closely one. Okay, so it's very much closer to cathode. So grid is right next to here. But this is just showing in the illustration. So the triode equals 3 electrons. Electrodes, plate, grid, and cathode. So it's 3 of these right here. K and all the tube hooks. Interesting. So now they just change it to a C. What in the world's going on here?
Every time a negative potential is impressed on the grid, even though it be very minute, it has a large effect in reducing the number of the negatively charged electrons which would otherwise keep flying from cathode to anode.
Okay, so like repulsions repel, and grid repels negative electrons. So it repels some here, so it's not all of them going to go here because you have if it's negative.
Conversely, when the grid is positive,
Okay, when a positive...
an equally large effect is exerted in increasing the flow of electrons from
So now if it's positive, it increases the amount.
cathode to anode. The important thing to note here is this. A small amount of power applied at the grid is amplified into a large amount of power in the anode or work circuit. This amplifying property of the three-element electronic tube is put to work in innumerable ways.
Okay, so basically when you have a positive one, it increases the output because of this setup there. So now let's say amplify triode tube amplifier, how it works. I just want to see how that works properly, and then also how do you get a radio signal? How it works to listen to a radio. Oh no, to amplify a radio signal. Bias is a charged place on the grid, so the tube sits idling, ready to blast, but not quite, not power to grid, but negative power on grid. Again, it melts it. Interesting. Let's see what do vacuum tubes do? Let's see what this guy says here.
This. So what do vacuum tubes or valves do? Well, they're comprised of...
Okay, this one is that setup. That's this one here. Glass tube. Anode is that plate. Cathode is a heated one. And then, so you have a heater inside. You heat it. Electrons go here. Okay, now let's see what this guy's talking about. And
a few different parts inside. The first one...
I want to understand how it, like, amplified. So let's say, yeah, you increase the power output, but how does that affect the guitar music listening or whatnot? Vibrate the grid with RF and get RF amplification. Okay, yeah, so the grid gets vibrating, and then you can go that. But again, I just want to connect it to, like, because you just get a higher reading. But what does that actual reading mean? How does that, because you get a higher voltage. But the question is, what does that mean in terms of the signal? So you get a difference, and you can actually know it. But anyways, it amplifies because of higher voltage across K to P.
Is the heater, and the heater's job is just to throw off a bunch of electrons. Now it does this in a vacuum, in the same reason that you have a vacuum inside your incandescent bulb. If there was any oxygen inside, that tiny filament would just burn up.
A small tiny voltage on grid causes much bigger. Okay, so the question is, yeah, so basically it brings up much bigger. Okay, and then from there you can detect it. But I wanna see how it is done practically. See what's going on.
So within a vacuum, there's no oxygen in there, and that side flow, and it's like on...
Okay, there's a grid there.
Within a vacuum, there's no oxygen in there, and that allows the stuff not to burn up. So the heater throws off electrons. On the other side of that, we have a plate whose job is to collect those electrons. In between, we have a grid, and a grid's job is to vary the electron flow and kind of modulate the blockage between the heater and the plate to vary those flow of electrons. Now, this is what it looks like on a circuit diagram. You might have seen a circuit diagram like this. In this case, we have...
Okay, so that's what it is. Okay, I think I've seen those before. You amplify the millivolts applied to the grid by throttling much bigger voltage current. Okay, so yeah, basically you get much bigger than the actual input. Because that's the thing I want to see, because if you have that, but you're actually getting much bigger than the actual input. So that's what I mean by amplifying, not just detecting it.
3 valves in the circuit diagram. And if we were to zero in on that symbol of a vacuum tube, we have our heater, we have our plate, and we have our grid in the middle. So let's zero in on that with those 3 parts there, the heater, grid, and the plate. And as I said before, the heater's job is just to throw off lots of electrons. And if there were no grid there, then all of them would just flow straight to the plate. But there is a grid there, and a grid's job is to vary that flow between the heater and
so basically think of a light dimmer. That's pretty cool.
The plate. So if that's kind of in the middle, then that will resist some of that electron flow, that current. So if we're to look at that grid, what could we send into that grid to modulate and open and close that? Well, we can send in a weak AC signal. What do you know that produces a really weak AC signal, a back and forth waveform? What do you know? Absolutely, a pickup. The pickup in your guitar, if it's connected to a grid, will allow you to vary the amount of those electrons that move from the heater to the plate. So your pickup is basically open and closing that variable resistance between the heater and the plate. And what do we get out of that? Well, we get a stronger AC signal that's coming off of the plate. Now, here's...
It doesn't resist because not heating. It more accurately repels electron cloud. Interesting.
Something that's very worthwhile kind of understanding. This stronger AC signal is not an amplified weak AC signal. In fact, the weak AC signal is just simply modulating the amount of electrons that are flowing from the heater through to the plate. So you kind of get that idea? That stronger AC signal is just an analogy of that weak AC signal. Now here's an analogy that might be able to make a little bit more sense. Imagine I'm using this faucet and I'm moving this lever back and forth. I'm not generating any water pressure, I'm just modulating that water pressure. You could think of this area down the bottom here as the heater. Here's our plate, and the lever adjusting the water flow is the grid.
Okay, yeah, interesting. Anyways, yeah, basically you have a different setup there. I'm just gonna see how is it actually done in practical setup there. I'm gonna go right here and Telegram. I'll post this video, and I'll post in this one here, summarize. And again, this one here, every time you summarize, you feed into Hive blockchain and Leo AI, and so on. And it's all open source, public, blah blah blah. The thing I want to do is, I think we had the other video. This one here. I also want to add this. Okay, I'm gonna go triode tube amplifying guitar. So how is it done with the guitars? What happens? Too afraid to ask. And then what is it connected to? Let's see this one right here.
Voltage. Adding a third electrode provides.
Okay, no, this is a interesting setups here. Put this here. Summarize. One of the best books on electrons is Art of Electrons at Horowitz. Interesting. Right. This is I'll hide this work thingy. And oh yeah, and also before we even get further, I want to see how this is done. I want to see how this is actually done. Cutting tool, Dutch diamond cutting machine. I'll just go like this. In operation. Okay, let's see. Cutting diamonds. How does it actually cut diamonds? Magic of two late 19th century Dutch diamond. Is there actual? Oh, it's gone. Let's go to videos. It's kind of what I mean. Like this is something that's pretty cool to see, but now it's gone. Art of diamond cutting. Diamond cutting machine. Antique diamond cutting machine. Now what do they use? Dutch diamond cutting. Yeah, let's see that if it makes sure the art diamond. It doesn't show anything. Let's go if it shows in here on videos. The last diamond cutters. Okay, they don't have that. Antique diamond cutting. Antique diamond cutting. You have to cut the antique diamonds. Antique old cut. Yes, it's like they don't have these. Someone show a diamond cutting. Unbelievable. Okay. Yeah, so anyway, so it's a diamond cutting tool. Okay, let's go here. Plate drives, output transformer, primary, secondary drive, speaker. Interesting. Okay, so you're talking more advanced than me.
Provides us with a valve that can amplify. In a basic triode valve, the small audio signal is applied to the control grid. This limits the larger current travelling through the valve, and the signal collected at the anode is a much larger version than what was applied to the control grid. Inside the AD30 we have 4 ECC83s, twin triode preamp valves. 4 EL84s, pentode power valves capable of delivering 15 watts in a push-pull pair. This amplifier has 2 pairs, giving a total output of 30 watts. And a GZ34 rectifier diode, because we all love that saggy bottom we get from high volume voltage sag.
Anyways, yeah, I pretty much understand it. Yeah. So basically, yeah, you have the weak signal, and now you have a giant, bigger signal that you can power bigger speakers and so on. And so, yeah, anyways, it's pretty straightforward stuff. And yeah, so this project thingy I'll be using, hopefully a Hive has a similar one, because I just want to use everything on Hive instead of these those stuff. Anyways, there's John Hutchison there. Yes. Anyway, so John says, "Brilliant, Matthew. Thanks. Great fun. Now we know." So yeah, so John and I are BFFs. RF vibration, piezoelectric cracking on the material boundaries, probably similar to how RF dustifies brittle materials. Interesting. Yeah, so RF, yeah, so basically, if you see my stream, 2 weeks ago, one before I went to John's place, I'm pretty sure, I think, according to this guy, so I think what's actually happening, and that's why I said, like, keep this in mind for future, is that radio waves are literally longitudinal electrogravitic waves. So in other words, it's not that radio wave. Let's go radio waves. Wiki. It's not the wiki version. We have a magnetic field on the right angle for some reason. It's not. Yeah. So this is again vibrating back and forth, and they're only showing electric field set up there. But what I'm trying to say is, see how this works. This goes up and down. So basically, your whole idea is you vibrate, and then you get this electric field going up and down, going side to side, in line with the setup here. It goes there, electric field goes there, goes there. There's a half pole that, and then, so that's how it is. And then they somehow say light is, yeah, so notice how it doesn't even show the light, let's say light wave. I want to show the, where's the light? Okay, light photon. Sketch of water wave showing. Okay, so we have water wave showing diffraction. So it's again water wave showing diffraction. Yeah, so this is it's not this. So what I'm trying to say is, this might not be the actual story. Like we have magnetic field to the side of it, because magnetic field's only created by moving charges, but there's no charges in a vacuum. So in other words, you can create a magnetic field just by moving electric field. So then, and this is where the guys, I'm putting this guy's paper in, because I'm pretty sure this is what happens. If you have radio waves of different frequencies such that the difference between them is, or just any electromagnetic wave, I mean electrogravitic wave. So if the difference between them is like super tiny, that's like subatomic or atomic level, that can create atomic changes, as opposed to using gamma rays. You can use multiple frequencies at slightly different shifts. Ether permeates all vacuum, one theory. Yeah, but again, this guy is the one who actually has experiments showing similarities. So like magnetic field will just be rotation of the ether, and then radio waves are just like longitudinal ether waves. So just like water. And I'll be putting all this guy's paper in there. Where's the rest of the paper? Because the question is, where in the world did it go? Oh, this paper's right here. So there's a link. Open this one. And download citation. Just ridiculous. Like, just open it. Like, you can't just open the paper? Like, are we in a different planet right now? Like, what's going on here? Yeah, so I'll have to go to the ether theory, and I'll be posting that again, because I need to keep reading that one. I'll be reading it more and more of it. I suspect 1 to 3 electromagnetic component particle radiation, high voltage gradient environment. Yeah, RF electromag. Basically RF. He has RF, multiple RFs. He also has a static. So like, but then that's pretty much like static magnetic field. Yeah, like Van de Graaff's. He also has a radioactive material, like low danger, but like inside a tube, high voltage. But the other thing that's key is he also has a lot of mass, a lot of metal that could either reflect the stuff back, or it could use some of that mass to it. So jump up Hurricane Aaron and steer it at NYC, harp on Ascension Island, and next round. Okay, let's go. He's already solved it. Where did all those stuff, extra resources? Oh, this is it. Okay, fractal. This is goes here, PDFs, Fundamental Ether, Part 4. I'll be uploading this, guys. Okay, so this one is Part 4. What did we cover? I'm gonna just start posting all these because I want to read this all, and then also right here, electron rod. What did I get onto this so far? I've gotten up to here. This is I4. Yeah, anyways, so I'll be reading this. We pretty much understood vacuum tubes. Is there anything else that we haven't covered? Pretty much nothing else we haven't covered, and so on. I was trying to. Oh yeah, actually, we could. Yeah, it's actually it's noon now. But yeah, so I'll be covering all this. I just want to see where did I end up off? Well, I put these two I5. What did I add up? This one. I added all these. Okay, so we still got to the introduction. That was just introduction. Yeah, so I got up to this one. This is hopeless. And then this is, let's see what it says here. Something said hopeless. Where does it get that? Oh yeah, that's it. Yeah, this guy here say I must say it's hopeless. And again, and then I did the next one. So this one here. So the illustrator. So basically, I'll be copying all this. And again, this is also if Mystic Bazaar is still here. This is kind of what I mean by putting stuff on Hive. So you copy this, paste this on the Hive blockchain, because this, again, in my opinion, this is very, 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 very close stuff. And again, it's kind of like main and like practical terms, like yes, theory of the ether, and then you go from there. But then here at MES, I try to connect it to Hutchinson effect. Because we need to actually do something that is prove it. Like, basically, we need to replicate a Hutchinson effect in my opinion, the simplest way, which is like just like a little miniature one with everything explained. Because ain't nobody else gonna explain it for us. All right, I7, and then I'll put these notes right here. I7 is this. Anyways, I'll finish this off, and then I'll send them an email when I'm done it. Anyways, I got a bunch of people messaging me, and I'm done now. Okay. Okay. Anyways, yeah. So that's all for today, guys. Thanks for joining. We pretty much solved everything. And save draft. Okay, why? Because I'm as well. Then, anyways. Alright, anyways, guys, that is all for today. Thanks for joining. I'm just gonna end the stream, and then we'll get back into the setup. And then this one, this Saturday we'll go over JFK. Alan Force joining the show again. He's gonna talk about his research on JFK, but it's a bit out there. I agree. So vital to replicate with certainty, not randomness of tweaking knobs and hoping for effect needs to be reproducible. Yeah, it's basically that is the name of the game. And it's like. It's the importance can't be understated. Yeah, but the other thing is open and public, because doing it the way I'm doing it, because because it's very, very. Okay, I'm just copying an article over to Inleo. Okay, I mixed up there. And also one thing about Inleo 29. I mean Mystic Bazaar. Inleo it doesn't have. I'm gonna end the threadcast. So it doesn't have the like when you put the title. It automatically goes into the URL, like automatically. There's no like adjusting it. So what I usually do is I give the title that I want in the setup here. Be like let's go MES 1 2 3, and then use that, and then I would post, and then I would edit the title, and I would use peak then anyways, because but you can work that around, because peak what you can do with peak though, which is cooler, but you don't earn the Leo, which is a downside. So again, there's a bunch of random stuff if you want. So you can go, if you go right here, let's go 1 2 3. I can edit the URL here. I can go make it 1, make it shorter. So other ones could be long, but again, that's pro tip. You don't need to worry about that. Just post your article with the headline and so on, and don't worry about this. I worry about this because I'm a bit nuts. Anyways, I'll delete this thingy. Delete. Okay, go back here. View drafts. Confirm. Delete. Okay, this is fundamental ether. Okay, anyways. Okay, so we have this one here. I'll save this draft. And yeah, anyways, that's all for today. And yeah, thanks for joining. Open source alt tech is the best way, but also like open, like in terms of showing people what's going on. So if anything happens to me, you'll know. You can at least like know where I got to before I got taken out. And have a great day. Because have a great day. Anyways. Because John Hutchinson, he wasn't doing stuff like, methodically, and that's probably why he's still around. But anyways, yeah, that's all for today, guys. Have a good one. And ending the stream in 3, 2, 1. Stop recording and